welcome to another episode of THP Tutorials. In today's video, we're going to be talking about operations management. We're treating the fourth week, that's managing projects, right? So these are the learning objectives for managing projects. We're going to learn how to use a Gantt chart for scheduling. We'll draw the AO activity on Arrow and activity on node networks. That's already been covered in another video. The link is in the description, so just check it out. So we'll be doing that over here, but we'll be making some references in this video to the one that has already been done. The third is how to complete the foreign number port pass for a project. That's also been done, but I will shed a little light on it, and determining the critical part also been done. Then we'll learn how to calculate the variance of activity times. That will be done in this video. It's not much, so just do it right in this video. Right, so let's begin. Please don't forget to subscribe. Yeah. So when we say project, what are the qualities of a project? What are the characteristics of a project? Right now, projects they all have an objective. They are all unique, and they are all of a temporary nature. Right? No project is permanent. You have project A, you get project A done with, and you move to project B. That's how projects work. They are temporary. Right? They have a beginning and an end. Now, they all have some degree of complexity, meaning that there's always a degree of difficulty in various projects. Some projects may be more complex than others, but nonetheless, there is always a degree of complexity, a degree of difficulty inside a project. Now, finally, all projects have to cope with some uncertainty, right? That's right. So there's always that factor of uncertainty in projects. There's always that possibility that the project might not come on, or maybe the project may not be completed in time, right? There's always that uncertainty because anything can happen, right? So managing projects is, it is said, like juggling three balls. Like juggling three balls: cost, quality, and time, right? Those are the channel: cost, quality, and time. You have to manage this very well in order to have a successful project. So what I thought is project management. When you say project management, what are you talking about? Now, a project is a set of activities with a defined start point and a defined end state, which pursues a defined goal and uses a defined set of resources, right? So you have a set of activities, that's one. And this set of activities have a defined start point, right? And also have a defined end point. And these activities are pursuing a defined goal, and they use a defined set of resources. Now, technically, many small-scale operations management endeavors, taking minutes or hours, conform to this definition of a project. Give examples of projects. What I'm doing right now is a project, like the Haven project. THP Tutorials is one of the projects that the Haven project is working on the current, right? We have a lot of plans. We'll talk about that later. Right, by the way. Now, what are the purposes of project scheduling, right? So you know that project has a start point and end point. There's a defined set of resources, and there's a defined set of goals or a defined goal that a project is trying to achieve. So, why should we schedule a project? One, to show the relationship of each project activity. To show the relationship of each activity to others and to the whole project, right? A project is made up of a set of activities. You would want to know how the activities are related to each other, right? Which activities must come first, so on. Two, identifies the precedence relationships among activities. That's just what I said, right? Precedence, which comes first, second, third, fourth, fifth, sixth. And that's also very important. You can't start a project and then you start at the end. You start from the beginning. So it's good to schedule your projects to have everything planned. 3. It encourages the setting of realistic time and cost estimates for each activity, right? If you know what you are going to do and how you are going to do it, you know the resources required to do it. So it helps you have a clear idea, a concrete figure on the cost that you'll be incurring when you are undertaking your project. 4. It helps make better use of people, money, and material resources by identifying critical bottlenecks in the project. Next, project management techniques. So what are the techniques used to manage projects? Now you have the Gantt chart after George Gantt, V. Henry Gantt. It's in management. He's one of the founding fathers, I think, in a scientific theories of management. Yeah, he has come over here too. Now, also the critical path method, that is CPM, and program evaluation and review technique, PERT, P-E-R-T. Yes, so we'll take all of them individually, right? So this is a typical example of a Gantt chart. This is obviously for a product or something. So you design a product, you have your prototype, you test the prototype. You, after testing the prototype, you know what's wrong and what's not wrong, what can be improved and what should be left the way it is. So you make all those revisions or you make those changes. Then you produce production, right? That's when you start producing the prototype. So when you get a final prototype that passes the testing completely or to a satisfactory level, then you start producing it on a large scale. So this Gantt chart is in months. It can also be in days. It can be in weeks. Very well. So we have January, February, March, April, May, June, July, August to September. Right, so this is telling us that this project is to take place in what? 2, 4, 6, 8. In a 9-month time frame. Right, so design is going from January to June. Right. Sorry. A prototype March, April. We'll talk more about this. Let's continue. Now, the critical path method, the CPM models. Now, the critical path method, it models the project by clarifying the relationships between activities diagrammatically, right? It uses diagrams to clarify the relationship between activities. Now, the first way we can illustrate this is by using arrows to represent each activity in a project. We use arrows to represent each activity in a project. Arrows. Yes. So you have the critical path method and the program evaluation and review technique. We are talking about all that, so don't worry. Yes. So what do you use the PERT and CPM for? Now these are some of the questions that these models can answer. One is, when would the entire project be completed? So it helps you to know the project duration. 2, what are the critical activities or tasks in the project? Now the critical activities are simply the activities that need to be completed on time. Let's say if activity B in project Falcon and activity B has to, there are those activities. There are some activities that have to be completed on time. If those activities delay, then the entire project will delay. That's what the critical activity is. Now, critical activities form the critical part. Again, we'll talk more on that. Just a little information. Now, 3, which are the non-critical activities? Just talk about that. Now, what is the probability that the project will be completed by a specific date? Get it? Right. So maybe you have a project and you say that I want to do this project, I want to launch a project in the next 3 weeks. If you use this CPM and PERT, it can help you get an estimate to know whether your 3 weeks deadline is realistic enough. Now, as I was saying, I've already talked about this is done in the video, but let me just brush to that. AOA stands for activity on arrow or activity on load, right? Sorry, activity on arrow or activity on arc. That's AOA, the network diagram. Now, since rule 1, an event cannot be reached until all activities leading to it are complete. That's 1. Rule 2, no activity can start until its tail event is reached. And 3, no 2 activities can have the same head and tail event. They must be drawn using a dummy activity, right? And the dummy activity only applies to activity on arrow or activity on arc. For activity on node, you don't need to use the dummy activity. You can just go ahead and I explained it in the so just check it out. It's in the link is in the description. Now, this is a comparison of AO activity on node and activity on arc or arrow network convention. These are the rules that are used to draw the diagram. That's the relationship between the activities. Now you have over here. Give me a second. Yeah. So on this side, that's the activity on node, right? And it says that A counts before B, which counts before C. So it's saying that the activity A must be completed before activity B can start, and so too activity B must be completed before activity C can start. And this is how you represent it, right? This is activity on node. Now this is where you see the difference. Whereas that over here the A is on the node, right? But over here for the AOA, the A is on the arrow, the activity is on the arrow, right? That's what is called activity on node. And this is called activity on arrow. So this is how you represent it. A before B before C. Now the B says for activity on, so the same thing for the activity on arrow, but whereas that the A is on the arrow, not on the node. Very well. Now for the B says what? A and B must both be completed before C can start. A and B must both be completed before C can start. So you have this. So you see, A and B must be completed before C can start. So it means that even if you finish A, you can't start with C until you have also finished B. That's why you have it like this. A, B, C. It would have been the same way if, let's say, you had a situation where activity A, B, and C must be finished before activity D is started. That was just like it. See. A, B, and C, D. Right. Exactly. Anyway, so this is how it's represented in activity on arrow. Again, you realize that the activity is on the arrow, it's not on the node. So that's the AA. That's why they've drawn another node over here. See, so A, B, and this. So over here, the node is rather representing time between activities. And you move to C, right? So this is the activity. This is the time between. And C is just a event. This time around, activity A must be completed before B and C can start, right? So it's just the other way around. Same thing too for this one. It's the other way around. And these are more complex. See, it says what? This says C and D cannot begin until both A and B are completed. Right? So A is, if I were to, let me try and isolate that so that we get a better understanding. See, let's say that C, and I says that C and D, right? C and D. So imagine it was like this. Let's say C must, A and B must be completed before C can come. That would have been something like this. I will C and have A. Right, so that will be like this. That will be, we'll see. Right, the same thing we have also gone for D. Okay. So how do you combine this? Right? How do you combine this? That's why you have to. So they just the goal is to make sure that your diagram is concise. So you avoid any extra lines. You shouldn't have a diagram where you have the unnecessary crossing of lines. It shouldn't be that way, right? So see, you have your A over here and your B. However, that before A can start, is both C and D that must be completed. So what happens? You draw your so that the same thing for this. So it's quite simple, but you must really take your time and go through it. If not, you get confused. You just try to make sure that you have a straight, like a concise diagram. There shouldn't be unnecessary lines going the unnecessary direction. Always try to keep your diagram within like a box. Maybe if you are drawing this way, let everything fit over here and we go in this direction. Don't be drawing your diagram then you bring it down like this. You are going down, Just let it be straight, right? So that's some guides to help everything. When I'm doing your diagrams too, and it's your first time and you're not that experienced in it, one thing that helps is just do your rough work first and know that you're about to make a mistake. So just do your rough work and then you erase it before you come and do your actual work. So don't see like you get it on the first try. When you master it, it becomes easier, but if you're beginning, it can be a little discouraging. So just do everything and try your best to make everything fit in a logical way. So sometimes you see this A and B here like this. There are some situations where it will be more logical for you to put B at the top and A at the down in order for you to have a straight diagram. So you just do that and just follow the rules that I've spoken about in this video. This is just another example, right? Now see, they've introduced a dummy activity. We are saying that with 3 over here, see with 3. If you say that no two activities can have the same head and tail events, they must be drawn using a dummy activity, right? This is what they call it. This is what is called a dummy activity. This line over here, this arrow, that's a dummy activity. And so let's look at situations or instances when a dummy activity will be needed. See, another one is over here. So let's explain more. See, say activity or node, no dummy activity is needed. Activity or arrow uses, I'm reading from this part. Okay. So activity or node, no dummy activity is needed. Activity or arrow uses dummy activities. 1. It separates two activities that have the same starting and ending nodes. Right? Two activities that have the same starting and ending nodes. And when activities share some but not all precedence activities. So see, this is an illustration of the second one. Right? Whereas that give me a second. This is an illustration over here. So A, when two independent activities have the same head and tail event. So you have this activity 1, activity 2, right? Sorry, this is the timing. So this is activity on arrow. So the activity is the X and the Y. See that this is the tail, this is the head. They are both sharing the same head and tail. So what was it done? X was diverted and given its own node. And then you use a dummy line to connect that node to this point. So you see that because you need the timeline to draw it. Another instance is when two independent chain of activities share a common event. So see 1, 3, 5, 2, 4, 6. This activity right here. Let's say this was X, right? Let's say this is Y, and this is Z. This is just trying to tell us that before Z would be completed, X and Y, before Z would be started, X and Y must have been completed, right? So, but X is also following its own chain of activities. So let's say after X here, this could be, let's say W. I didn't use the right alphabet, right? I take like W. So X is comes, then W comes, right? So you cannot connect X over here because it has its own chain of activities. So this node that has over here, you just draw a timing activity to this node, then you link it to the Y. So this clearly states that X and Y must be finished before Z can be completed. Right, so that's it. Now this is an example. We have a whole practical machine on this, so don't worry about it. Just check out the video. The link is in the description once again. Please subscribe if you haven't, and tell a friend from you. For us, right? Help us help you. That's why you are here. The Heaven Project. Now, this gives a iteration of what I've been saying. So you have a done activity over here as well. Right. A, B, but D has to be completed with. So let me just explain it quickly and we move on. See, this is activity D, right? Activity D had to, before activity D could start, A and B had to be completed. But how do you represent that on activity, right? A and B. A comes before C, so it has its own chain of activities. It's going its way, right? So you can't just reroute it to D. So what you do is that you do an activity on node 2 over here, and you bring it down, bam, and you go. That's how it's done. Exactly. Now, how do you determine the project schedule? To do that, you perform a critical path analysis. That's why you have the earliest start, which is the earliest time at which an activity can start, assuming all predecessors have been completed. Right? Predecessors being the activities that come before that activity. Earliest finish, the earliest time at which an activity can be finished. So if you have activity A and activity B, and A must be completed before B continues, the earliest finish of A becomes the earliest start of B. So too for the latest finish and latest start. Now for the latest start, latest time at which an activity can start, so as not to delay the completion time of the entire project. Same goes for latest finish. Once again, all of this has been done in the video. Just check the link below and you have access to it. Forward pass also been done. You have nothing to worry about. Yeah, okay. This is slack time. So what's slack time? Now, after computing the earliest start, earliest finish, latest start and latest finish times for your activities, you compute the slack or free time for each activity. Now, slack time is the length of time an activity can be delayed without delaying the entire project. Remember what I said about the critical part? So all activities without a slack time are on the critical part. If you complete the slack time, which is either late start minus earliest start or late finish minus earliest finish, you require. So you see, this is how you compute for your slack time. And if you get 0, means that activity is on the critical part, not on the critical part coming soon. Now, See, we completed this right over here. Just like I said, it was true. So A, B, C, D, E, F, G, H. Yeah, so activities. These are coming from the diagram that we drew. Let's start this. These figures are what you are seeing. Right. Let me go back a little. See, earliest start this corner. Earliest start here. Yes, earliest finish here. Earliest, latest finish, latest start. These two, the product duration. Right. Very good. Now going back, all the way back. So you see, the time it has been computed, and you have 0, 1, 0, 1, 0, 6, 0, 0, 0. Right. So it means that activity F can be delayed for 6 days, and the project will still be completed on time. So there you go. Aha. Now, when you do a diagram, when you watch the video, I see this also in the video, but looking at this diagram, I realize that some of the arrows are different. Those are like, that's the critical part. The one with the big blue arrows, the bolding blue arrows. Sorry. Now, one way of recognizing or identifying the earliest start is, see the earliest, the critical part. The activity on the critical part will be 0, 0, 0, 0, right? 0, 0, 2, 2. So the same logic. So yes. You do that. Earliest start minus latest start will be 0. 0 minus 0, 0. 2 minus 2, 0. 2 minus 2, 0. 4 minus 4, 0. 4 minus, all you're going to give you 0. So that's how you identify your critical part. And these are the activities that must be finished on time. If they're not finished on time, the project will be delayed to the degree of the delay in the completion of these activities. Now, see, after you have completed our earliest start and our earliest finish and all that, now you can use it to draw a Gantt chart, right? So you realize over here, look at the last diagram, the last node activity. It was 15, right? So now we draw our Gantt chart, so that we need 15 days to complete our project. So we did just 16 days. And it has been mapped out. So you have activity A, B, C, D, E, F, H. The earliest finish was 2 for this one. It was 3, it was 4, going on. So this is how we do a Gantt chart. Right. Now, variability in activity times, right? Now, CPM, not the critical path method, assumes we know a fixed time estimate for each activity, and there is no variability in activity times, right? So the CPM, the critical path method, assumes that we know a fixed time estimate for each activity. That's the first assumption, and there is no variability in activity time. So activity times does not change. It's there, rigid. Now, for Pert, that's a program evaluation, and so Pert uses a probability distribution for activity times to allow for variability. Pert uses a probability distribution, normal distribution, for activity times to allow for variability. So PERT, Pert allows, or it accounts for variability in activity times, right? So there are 3 time estimates required. There's the optimistic time, that's A. If everything goes according to plan, then we are optimistic that we finish activity A in 2 days, or maybe finish the entire project in activity not project. Activity A in 2 days, B 6 days, so on and so forth. Now the pessimistic time is assuming very unfavorable conditions. So that's like if weight becomes worse, how long will it take us to complete this activity? So that's given by B. Optimistic is given by A, right? Now, most likely time. So realistically speaking, what's the most likely time that you can finish this activity and move on to the next? So this is how you compute it, right? You have your expected time T, which is given by what? A plus 4m plus B all over 6, right? That's how you can compute your expected time. So you have it in your table. Get it? But this is just for making it square. Or maybe I just like writing on the board. And 6, right? So this is how you calculate your estimated time. Anyway, now if you want to calculate for the variance of the times, variance V is given by, as you can see right here, V minus A all over 6 squared. Right, over 6 squared. So there you go. Have it in your. So this is how you get your expected time, get your variance. So all you need is to have the formula over here. So automatic time A, M, B time. Let's compute it. So this will have been, that's what A is 1, M is 2. So 1 plus 4 times 2 plus 3. So 4 times 2 is 8. 8 plus 3 is 11. Yeah, 11. 11 whereby so 1 plus 4 to bracket 2 plus 3. Whatever I see. Oh yeah, the answer is 2. The answer is 2. Yeah, plus the 1, so it's 12. So the answer is 2. So yeah, that's the formula. Let me try for the variance and see what happens. So that would be B minus, so that would be 3 minus 1 divided by 6. 3 minus 1 divided by 6. 0.33. So answer squared. Yeah, 0.11. So that's how you compute the variance and the expected time. Some of these have been solved in the. Some of these have been solved in the video. Not all was solved. So just a few examples. Give you a general idea on how it goes. Yes. Yeah. Probability of project completion. Right. So what's the probability that the project will be completed? So project variance is computed by summing the variance of the critical activities. Right? So this is the summation sign. This is the summation sign. So variance of project. So that's project variance, right? It's equal to the summation of the variances of the activities on the critical part. Yeah. Now, cost minus time trade-offs and project crashing. Yeah, so the cost time trade-offs and project crashing. Now, when you are managing your project, it's not uncommon to face the following situations. The project would maybe fall behind schedule, and also the completion time might be moved for a day. It might become necessary for you to move your completion time forward. So don't stress, it's normal. It happens all the time. Now, shortening the duration of the project is called project crashing. When you shorten the duration of the project, you are crashing the project. So So what are the advantages of this method, this Pert and critical path method? So project documentation and graphics point out who is responsible for various activities, right? And it's applicable to a wide range of projects. It is useful in monitoring not only schedules but cost as well. Those are some of the advantages. No, it won't come here now. Now, limitations of Pert or critical path method. One, the project activities have to be clearly defined, independent, and stable in their relationships. Precedence relationships must be specified and networked together. 3. Time estimates tend to be subjective and are subject to fudging by managers. There is an inherent danger for too much emphasis being placed on the longest or critical part. Right? So these are the limitations of Pert and CPM. Thank you very much for your time. Please don't forget to like and subscribe. See you in tutorials.